It explodes and destroys New York City, parts of Connecticut and New Jersey. This is one of the great mysteries of physics, a wonder of the night sky. Betelgeuse is a red giant in the constellation Orion that has fascinated astronomers for generations. Recent updates from renowned physicist Michio Kaku have raised concerns, suggesting that Betelgeuse has exploded. How this explosion will change our understanding of the life cycles of stars and the forces that shape our universe is a big question. What are the implications for us? Stay with us to find out. Imagine looking up into the night sky and seeing a bright star in the constellation Betelgeuse, also known as Alpha Orion. Orion, a spectacular constellation with approximately 5 hours and 30 minutes of right ascension and no descent, takes its name from the famous Orion of Greek mythology. Known for its brightness, Orion has several famous stars, and Betelgeuse, a variable star with a reddish color, is the 11th brightest in the world at magnitude 0.6. Betelgeuse is worth mentioning as the crew's brightest star, shining like a beacon over the hunter's shoulder. The name Betelgeuse comes from the Arabic word bat al-Jawza, meaning shoulder of the giant. In 1603, astronomer Johann Bayer gave the star its name, Alpha Orionis, reflecting its status as the brightest star in the Orion constellation. Interestingly, although Rigel is now recognized as the brightest in Orion, Betelgeuse has retained its name with pride. Betelgeuse is a massive star, 764 times the mass of our Sun, and is the most massive star in our solar system. Visually, if the Sun is a small marble, Betelgeuse is a large basketball. Determining the distance of Betelgeuse is very difficult, and is estimated to be 500 to 600 light-years from our Sun, which is quite far in the universe. At its brightest, Betelgeuse shines with a magnitude of 6. Harvard University researcher Morgan McLeod says Betelgeuse's proximity and size make it one of the few stars that scientists can study up close using telescopes. Floor and space-time. Telescope images reveal Betelgeuse's unique features, revealing a unique surface of the Sun's smooth surface. Instead of looking like superheated plasma, Betelgeuse appears as a collection of gas pockets, bubbling, about the size of small stars. A huge upsurge of hot material from Betelgeuse's core rises to the surface, similar to cleaning the sky. One of these shells is so massive that it takes 75 years to travel at the speed of the Moon. This process, known as surface mass ejection (SME), ejects material from Betelgeuse's outer layers, similar to the mass ejection of the Sun. Despite the differences in structure and internal processes, Betelgeuse is very young compared to our Sun at 10 million years old. Despite its young age, Betelgeuse has run out of hydrogen fuel in its core and is entering the final phase of its life by entering a red supermassive phase. At this stage, Betelgeuse uses helium to produce carbon through fusion processes, showing the rapid evolution that its initial mass has driven at birth. According to scientists, Betelgeuse began its journey through space as a blue-white star, belonging to the largest class of hydrogen-burning main sequence stars in the universe of stars. Size is related to luminosity and heat. Bigger stars like Betelgeuse are brighter and hotter, but they also accumulate hydrogen more quickly and transition past the red giant phase. Betelgeuse's surface reached 85,000 degrees Fahrenheit, a sharp contrast to 10,000 degrees Fahrenheit. As Betelgeuse used up its hydrogen and began fusing helium, its outer layer expanded, making it one of the most massive stars we know, more than 700 million miles wide. Currently, Betelgeuse's surface temperature is 5,800 degrees Fahrenheit, cooler than the Sun, but it is 7,500 to 14,000 times brighter than the Sun. In 1836, astronomer Sir John Herschel observed variations in the brightness of Betelgeuse, which led to its classification as a variable star with periodic changes and sometimes different. Basically, Betelgeuse follows a 400-day cycle. In 2019, however, it deviated from its past. Betelgeuse's erratic behavior due to random changes was noted. Historically, the brightness has varied in a continuous 400-day pattern, peaking at about 0.3 and falling at about 0.8. These differences are linked to the outer layer called the photosphere, which transmits most of the star's light and heat. The rotation in the photo, as heat moves from the inside to the surface through the air, the brightness changes over time. In the fall of 2019, Betelgeuse experienced the Great Dimming, which has decreased by about 60%, indicating a change from the previous pattern. The cause of the mass ejection is the formation of a large dust cloud that obscures our view. Although the dust cloud has disappeared, Betelgeuse has not fully returned to its former state, with its 400-day brightness cycle reduced to 200 days. Betelgeuse's unpredictable behavior sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star consumes its remaining fuel, its core collapses, giving rise to a black hole while expelling outer layers at speeds up to 25,000 miles per second. If Betelgeuse undergoes a supernova explosion, it would be a breathtaking display, visible for several weeks, similar to the full moon, due to its proximity of just 650 light-years. While star explosions are common, they're often too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a remarkable event for night sky observers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. Betelgeuse, the star in focus, is believed to have experienced a supernova. Astronomers generally estimate that Betelgeuse could pass within the next 100,000 years. A recent study by Hayuki Seo and his colleagues at Tohoku University suggests that it is at a higher level and is about to explode. However, opinions differ on the validity of this decision. What if Betelgeuse leaves? Supernovas are common, but rarely are they close enough to be visible with the naked eye. Betelgeuse's proximity makes it a unique case. While the explosion wouldn't pose a direct threat to Earth, it could lead to minor atmospheric effects, like a temporary reduction in the ozone layer due to ultraviolet radiation. Astronomers predict that when Betelgeuse goes supernova, its brilliance will shine like the full moon for weeks, then gradually wane over several months. This extraordinary celestial event would mark the end of Betelgeuse's life, but it would give humanity a rare front-row seat to one of the universe's most spectacular phenomena. Recent studies suggest Betelgeuse may be closer to a supernova explosion than previously thought, but there are differing opinions on the timeline. Some scientists believe it could explode within 1,000 years, while others estimate it could take up to 100,000 years. When Betelgeuse does explode, Earth's instruments would pick up signals such as neutrinos or gravitational waves, possibly giving us a heads-up a day before the event. While we may not witness Betelgeuse's supernova in our lifetime, one thing is certain: the night sky will forever change when it happens. Thanks for watching. Don't miss the video on your screen right now.